Hello everyone. This exercise is a very classical exercise in life insurance mathematics. Remember that we talked in the course about different concepts. We talked about the future lifetime random variable, survival probabilities, mortality probabilities. We talked about individuals aged 0 years old, X years old. We talked about the force of mortality. All these different concepts can be linked using the formulas that we derived in the course. So in this exercise, for example, you are given the survival function of a newborn as 0t, and then from this survival function we can calculate survival and mortality probabilities for different ages, and we can calculate a force of mortality. I will show you how we can do that. In the first question, we have to show that the survival function S0t, which is given by 100 minus t divided by 100, is a valid survival function. Note that S0 is a function of t, and t can take values between 0 and 100. What are the conditions for a survival function? First, it should start in 1. S0 evaluated in 0 should be 1, meaning that you are alive at the moment we determine your probabilities. Second condition, S0 as t becomes larger and larger should converge to 0, meaning that you have to die somewhere in the future, unfortunately. And the last, third condition, states that S0t is a decreasing function, non-increasing to be exact, of t. It means that over time your survival probabilities will always go down and down. Alright, we start with the first condition. If we evaluate our survival function in 0, we get 100 minus 0 divided by 100, and that is clearly 1. The survival function starts in 1. The second condition, if we go to plus infinity, my survival function should be 0, but note that in our situation t is only defined from 0 to 100, meaning that everyone has to die within 100 years. You cannot breach the age of 100. So we evaluate the survival function in the largest t, which is 100. Then you get 100 minus 100 divided by 100 gives you 0. Eventually your survival function goes to 0. And the third condition, we have to show that it's a decreasing function of t, so we take the derivative, and you can easily see that the derivative is minus 1 over 100. It's negative, meaning S0 is a decreasing function of t. To be more precise, the function S0 goes from 0 to 100. If we are in 0, my function takes the value 1. If we are in 100, my function takes the value 100, and we have a linear function, so I go down in a linear way from 1 to 0. This is my function S0 in function of t. In the second exercise, we have to determine the probability that a newborn dies between age 1 and 2. So we look for the probability that my future lifetime random variable t0 is larger than 1 and smaller than 2, which I can write as the difference of two probabilities. First, we look at the probability that you die within 2 years, and then I subtract the probability that you die within 1 year to have the probability that I'm exactly in between 1 and 2. I can switch from mortality probabilities to survival probabilities, because probability of dying in 2 years is 1 minus the probability of surviving 2 years, and I can do the same for the second probability. If you look into this formula, we see that this here is the survival function evaluated in 2. And this probability here is a survival function evaluated in 1. So we can rewrite the formula as S01 minus S02. It's a difference of two survival functions, and I know the survival function. I know that S0 in 1 is 99 over 100 and S0 in 2 is 98 over 100, gives you 0.01. There is a 1% probability that you will die between the age 1 and 2 if you are a newborn. In the third question, we need to determine the survival function of someone who is 30 years old. So we have the survival function of someone who is 0 years old. S0t, it's 100 minus t divided by 100. And now we have to calculate S30t. What is this? Let's calculate the survival function S of someone who is x years old. And then later we can put x equal to 30. We can always jump from the survival function of someone who is 0 years old to the survival function of someone who is x years old with one of our very important expressions. In this case, we know that sxt can be expressed as the survival function of someone who is 0 years old evaluated in x plus t divided by S0x. So it's important that you know this formula. If you know this formula, you can solve this type of questions easily. You can easily convert survival functions of someone who is 0 years old to survival function of someone who is x years old. And actually you can always jump from one age to another age. Alright, because now we can just plug in expressions for S0. S0 evaluated in x plus t, it's 100 minus x plus t, so minus x minus t, divided by 100, and S0x is 100 minus x divided by 100. Then this cancels and you get 100 minus x minus t divided by 100 minus x, which I can write as 1 minus t over 100 minus x. In case x is equal to 30, you find S30 in t, it's equal to 1 minus t divided by 70. In this case, I can take values t starting in 100 all the way to 70. In this case, I cannot take t larger than 70 because if I'm 30 years old, I survive for 70 years, I reach the age of 100, and in this model, you can never breach that age. In the last question, we have to derive an expression for mu x, the force of mortality of someone who is x years old today. The force of mortality can be calculated using the survival function. So we have a formula that tells you if you have the survival function, then this is the force of mortality. We have another formula that tells you if you have the force of mortality, then this is your survival function. In this case, we use mu x is equal to minus 1 over S0x times the derivative S0x. This formula tells you if you have S0, you can determine mu x. We use the expression for S0 to find that minus 1 over S0 is equal to minus 100 over 100 minus x. And we already calculated the derivative, it was equal to minus 1 over 100. So I find that the mu x is equal to 1 over 100 minus x. Where you see that the mu x is going to increases to infinity when x goes to 100. It means that the closer you reach the age 100, the larger the probability is that you will die shortly after. And in the limit, if you almost reach the age of 100, you will almost surely die directly after you reach that age.